Okay, completing the square. We're going to quickly do a problem that is like the ones that we've already seen. If we have something like x squared plus 8x plus 7 equals 0. And remember, the instruction here would be something like solve for x by completing the square. If they didn't say by completing the square, how could you solve this for x?
By finding 0.
Yeah, just finding the zeros. So factor, and we say x plus 7, x plus 1. Oh, x is either negative 7 or negative 1. So that's probably quicker in this case. The nice thing about completing the square is it will work when factoring doesn't work. But just for practice, we're going to do this kind of simpler one in completing the square form. So the first thing I want to make sure I have is, does the equation equal 0 or a constant? Is that true? In other words, do I have my x squared and my x on one side of the equation? Yes, that's already true here. The other question I have to ask myself is a equal to 1? And this is a step that we didn't talk about last week, but we'll talk about today. Is a equal to 1? Remember, a is the coefficient on x squared. In this case, it's equal to 1. Yeah?
So since 0 cannot be negative or positive, and the opposite of 0 is infinity, it's possible to have a negative infinity.
You can have negative infinity, yeah. True. Next step. We're going to have x squared plus 8x plus something equals, I'm subtracting the 7 off, so I have negative 7. So this step, what I did was subtract the constants. I'm getting rid of my constant term. But I'm leaving a space. This is what we call completing the square. Half of 8 is 4. 4 squared is 16. If I add 16 to this side, I also have to add it to this side. So I'm just going to rewrite this. I have x squared plus 8x plus 16 equals negative 7 plus 16 is positive 9. Right? So what we did was find half of b, square it, and add it to both sides. Half of b was 4. 4 squared is 16. Add that to both sides, and we get this. Next step is to factor x plus, and I know that my second term in my factor is going to be that. X plus 4 squared equals 9. Next step is to solve for x. I take the square root of both sides. Over here I have x plus 4. Over here I have plus or minus 3. Square root both sides. Remember the plus or minus.
I'm still kind of confused by the plus or minus.
Well, what does square root mean? Square root means I have two things multiplied together that equal 9. Right? So the square root of 9, 3 times 3 equals 9. So the square root of 9 is 3. But negative 3 times negative 3 also equals 9. 9 is either positive 3 or negative 3. And we could write it out as, like instead of writing that, we could write 3 or negative 3. But this looks really weird because we have this equation, right? We have x plus 4 equals 3 or negative 3, which is really two separate equations. And so with quadratics, it's just always left as this plus or minus thing. It just makes it a little bit more elegant to write. You don't have to write the, or it looks more like an equation. We don't have any words in there. And so we just write plus 3 or minus 3. Next step, subtract off the 4. So we have x equals negative 4 plus or minus 3, which now we write it as two separate equations. X equals negative 4 plus 3, which is x equals negative 1, or x equals negative 4 minus 3, which is x equals negative 7. Beautiful. X equals negative 1, or x equals negative 7. But, can I erase the first 3 steps? Speak now. Okay. What if we have something that does not have a does not meet these two first conditions? Okay, so something that has an a or that doesn't equal 0. So let's do this one. 4x squared minus 4x minus 8 equals 0. Does the equation equal 0? Yes. Is a 1? No. So what we're going to do, if a is not 1, we divide everything by a. So I'm going to divide everything by 4 on both sides of the equation. 4x squared divided by 4 is just x squared. Now a equals 1. Negative 4 divided by 4 is negative x. Negative 8 divided by 4 is negative 2. And 0 divided by 4 is 0. All right. Can I erase the rest of the first problem? Now I need to find, well, let's first add our constant over. Almost forgot to do that. X plus something equals a positive 2. Half of b is negative 1. Negative 1, that's not true. Half of b is negative 1/2. Negative 1/2 squared is 1/4. So I'm adding a 4th to both sides. The 4th is 0.25. Do you guys agree?
Yeah.
Okay. I wrote it as a fraction here and a decimal here. Then I'm factoring x minus 1/2 squared equals 2.25. Take the square root of both sides. This is where, if you don't have a calculator, this is a lot easier if it's written as a fraction, right? 2.25 is 9/4. And I can take the square root of 9/4 without a calculator. Right? Yeah, it is square root of 9, which is 3, over square root of 4, which is 2, plus or minus. Now I'm going to add 1/2 to both sides. So I have x equals 1/2 plus or minus 3/2. 1/2 plus 3/2. 1/2 plus 3/2 is equal to 2. 4/2. 1/2 minus 3/2
-1.
is equal to -1, which is -2 over 2. So my answers are 2 or -1. I always find it amazing when all these like fractions that we square and then take the square root of come out to just be integers. It seems so incredible that that can happen. But it will happen fairly often with completing the square. Sometimes it won't. And remember, if it doesn't, it's totally fine to leave your answer at this stage. So if I had something like x plus 1 equals plus or minus the square root of 5, I could just subtract 1 from both sides, and I could just leave my answer as -1 plus or minus the square root of 5. If I don't get a perfect square here, it's fine to leave the square root in your answer. There won't be any like that tonight, so I'll remind you of that again later. This was the step that we added, dividing by a. Yeah.
So I'm honestly curious. Where on earth would you use this in everyday life?
Where would you use completing the square?
Yes.
This is, I think, the only thing that I would never use unless I were taking a standardized test or teaching algebra. The reason is that people said that. They were like, why are we going to do this crazy process over and over? And they derived a formula that totally bypasses completing the square. And we'll do that by the end of this week. So this is the one thing that I can pretty honestly say, outside of like the context of studying algebra, I would never use completing the square. Where would I use the quadratic formula, which comes from completing the square?
Absolutely.
You would use it all the time if you were an engineer or mathematician. My wife the other day was watching this documentary about that missing plane. She was like, you gotta show this to your math students. You have to tell them they're using algebra to find this missing plane out in the Indian Ocean, right? Which she thought was super cool. And it is really cool, right? They use basic algebra to find this plane that went missing with all these passengers, right? And that's like the basic premise for their $35 million investigation of this plane, is that using this algebra, which involves some quadratics and different things, they could find where the plane must have landed. Quadratics in general, so the topic that completing the square is a part of, are used a lot. And that's because gravity, the pull of gravity on any planet, or between planets, or between the sun and the planets, is a quadratic function. And so when we want to model how orbits work, how we can get something to leave orbit, how gravity works on Earth when we throw an object or shoot an object, we're going to end up using a quadratic. So if you're designing like some sort of a super-powered weapon, right? The projectile that you shoot from that weapon is going to follow the path of the parabola. And if you want to be able to predict that, you would use something like the quadratic formula. Solving for x is basically knowing where is this object going to hit the ground. And of course, it gets much more complicated when we try to factor in real-life variables like wind resistance and aerodynamicness of the object that's floating through the air, and possibly that object also has its own source of power. But the basis for that calculation is a quadratic. And the basic thing that you're doing is finding the zeros. Finding what x equals will tell you where that would hit the ground. Yeah. And that's just one application out of many possible ones, but it sounds really cool to talk about super weapons. Yeah.
Why don't we have more customized education nowadays? Like,
Let's turn off the video because we're getting a little bit off.